I keep mentioning again and again that we are talking about interference of reflected light in thin films. I never really explain what exactly is a thin film. So let's try to talk about thin film first. So how does a thin film looks like? Let me give you a few examples of thin films that we can talk about. So the first one will be a soap bubble that we can see over here. So this is a soap bubble, and of course I believe you know that the thin film is referring to the soap layer that we can see over here. Okay, so basically when we talk about thin film, it involves a specific material that forms a very thin layer. Okay, so there's always, let's say for this thin film over here, that thin film will be the soap, but above the soap there's another medium, so there will be light traveling from one medium to another medium. So in this case, above the soap film you have air, okay, because air is light is traveling in air first, then it hit onto the soap bubble. Okay, of course below the thin film there's also air as well, because there's air above, which is outside the bubble. There's also air below, which is air inside the bubble. So in this case you can think of it as a three media layer. So the first medium will be air, there's air on top. Then the second medium in the middle, sandwiched in between, will be our thin film, and our thin film is made of soap. So it's air, soap. Then below our soap layer will be our third medium, which is the medium, in this case air. So in this case our three media will be air, soap, air. So this is the thin film case that we first look at for now. Another classic example of a thin film, it's this one. You can see there's a bit of oil spill on the road. So a bit of oil spill on the road, so the oil will form a very thin layer on the road. And for this case, if you try to understand the three media for this case, again, everything about thin film, we need to think about the three media. So our three media above the thin film, which is above our oil layer, there's air, because light is traveling through your air and hits onto the oil layer, right? So it's air, then your thin film, which is oil, then below our thin film will be our third media, and I believe you know that the oil is on the road, so the third medium will be the road. So it's air, oil, road. Okay, so always be very clear what is the thin film, then what is above the thin film, and what is below the thin film. You always need to be very clear what are the three media, then if you know the index of refraction, you can tackle the questions quite easily. Okay, one more example that we can see over here is the tempered glass that we usually stick onto our smartphone nowadays. So our tempered glass is the thin film. Okay, it's not exactly very thin, but it's good enough for our discussion over here. So our tempered glass is the thin film. So above our tempered glass there's air, below our tempered glass there's a screen, so it's air, glass, screen, something like that. Okay, of course it can change a bit, depends on the situation, but I believe roughly you see the idea. We know that there's a very thin layer. That is our focus. Then we need to know what is above that thin layer, what is below that thin layer. Okay, so I believe for all three examples that you see here, you might notice that they always have some kind of a rainbowish color on these films. Okay, or if you look at soap bubble, there's sometimes you can see some rainbowish color on it. Oil spill also, if you look at certain angle, you see quite a nice rainbowish color as well. And same for some glasses, like your reading glasses or your smartphone tempered glass. Occasionally from a certain angle you can see some rainbowish hue to it. Okay, so those kind of rainbowish hue is actually caused by the interference of reflected light. But why is it so? That one I'll explain a bit later. But right now you can see that all these films, they have similarity, and when you observe them, they have a rainbowish hue, and this is actually caused by the interference of reflected light. Okay, so let's try to see where is the interference exactly. It's just a thin layer. Where do you find the interference actually? So again, your thin film setup usually has a medium above the thin film. This green medium is above the thin film. You have your pink medium, which is below the thin film. So there's always three media that we want to focus on. In this case, medium 1 is usually air, but not always the case. Medium 2 will be other mediums such as glass, oil, soap, things like that. Medium 3 will be another medium. Sometimes it can be air, sometimes it can be glass. There are many examples over here. Okay, so our thin film here has a thickness of T. Okay, the thickness of this film is represented by small t over here. So now again, interference is the overlap of two or more waves. So we need to see where are the two waves actually that we want to overlap. Where can we find the first wave? Where can we find the second wave? Well, again, those are reflection, so you need to be very careful where does the reflection happen. Okay, so let's go. So today you have incident ray incidenting on this boundary over here. This is the boundary between medium 1 and medium 2. Or you can also think of it as the upper surface of this thin film. This thin film has a finite thickness, so this boundary here will be the upper surface of the thin film. So now when the incident ray hits onto the upper surface of the thin film, we learned from just now that what will happen? There will be some amount of reflection, at the same time there will be some amount of refraction. So here you have your reflected ray from the upper surface of the film. So this is what comes down then get reflected off the upper surface of the film. At the same time, there's there's also some amount of light that transmit through this boundary, entering medium 2, entering the thin film. Okay, so this is what happened. They happen at the same time. Okay, sometimes you have more reflection, sometimes you have more refraction. It depends on what type of media is it. Okay, so when your light enters the thin film, you approach the lower surface right now. So when you approach the lower surface of the thin film, this is the boundary between medium 2 and medium 3, right? So there's a change of boundary. Of course, a similar thing will happen, which is a combination of reflection and refraction. So now you see a second reflection that happened. This is the first reflection that reflects off the upper surface of the film. This is the second reflection that shows the reflection of the lower surface of the film. So this is the second reflection. And of course, some amount of light will also get transmitted through to medium 3. Okay, but of course you read the title, this is interference of reflected light, so I believe you know it is the reflected light that gets interfered. Okay, so right now when your light get reflected, it will approach the boundary between medium 2 and medium 1. So again, you reach the boundary, so what will happen? Reflection plus refraction. So some amount of light will get reflected off, some amount of light will get refracted off. Okay, so right now you can see that there's a pair of light wave that gets reflected off this thin film. The first light wave gets reflected off the upper surface of the film, whereas the second light wave that comes out from the thin film gets reflected off the lower surface of the film. So again, the first ray over here comes from this reflection, incident, reflection. Okay, but for the second one, it gets reflected off the lower surface. So it travels downward, gets transmitted first, then only it gets reflected and transmitted. Okay, so one time the reflection happens here, the second time the reflection happens here on the upper surface and the lower surface. And the reflection from the upper surface will then overlap with the reflection from the lower surface. So you have two waves right now. If they overlap in the same region, interference will occur. So our focus actually is just these two beams over here, and this is the reason why interference occur. Okay, in our situation, yes, these two reflected light will interfere with each other. Okay, so in our syllabus later, I'm going to simplify our diagram, just call it as medium 1, medium 2, and medium 3, where medium 2 will always be our thin film. Then later on, we'll be studying scenario 1, scenario 2, scenario 3, which involve different combination of index of refraction for each material.